Yeah, hi guys again because I'm recording that translation again because the previous one was the last part was not recorded, and the last part actually was really important because it shows the real connection. What I was, what I was trying to say by all this preparation before. Let me show my screen. It will be really short video. I hope you can see. Yeah, I was saying that yeah, we already find out that Cauchy theorem by this connection of U and by this isomorphism, let's say, and that our action has minimum not only by on one trajectory, but the homotopy class of trajectories between 2 points on that manifold. Yeah, I was even drawing here. Let me connect my pen. 1 second. Yeah, here I was saying that. Where is my? Oh, yeah, it's here. Yeah, as I said that the S has minimum not in one trajectory, but in the homotopy class of trajectories. What it means that we have 2 points like here. Yeah, 2 points. For example, here I, A, and B, and our action has a minimum not only by this one trajectory, but also the homotopy class of them and what interpretation gives it us. It shows us that for example, we have the particle P, and it can move from point A to point B, and that all these trajectories between them, this homotopy class, is the same for him. But he chooses one particular trajectory by some particular, how can I say, the particular probability, yeah, probability, by the one particular probability. So, or just for example, we have one region in that homotopy class region. We have one region, and our particle choose that region with some particular value of its probability, and it's just the pure quantum mechanics. If the initially our in classical mechanics it was only how can I say, let's say the trivial homotopy, because in classical mechanics where only the only one the homotopy, for example, we have the image in the phase space or any kind of space, and the trajectories on it, it can be factorized into only trivial homotopy classes, where each trajectory between 2 points it's homotopic to its own self, but we cannot let it be the trivial homotopy. But in classical mechanics, we didn't look at non-trivial ones. We don't have, maybe, I don't know. But if you consider in Cn, probably yes. And we have non-trivial homotopy class. So it arises the space for the quantum mechanics. Yeah, this is the first thing. And at the end of the video, I did a small summary of what I said in the whole video. Yeah, the first this video can be split into two main parts. The first part is about algebra and physics, the connection between them, and how what group structures, what group actions might be in correspondence with some particular physics or classical or quantum. Yeah. And the second part is about differential geometry and the complex analysis, and about homotopy too. But I'm also saying that I'm not really professional. That I'm just I have some little notion about them, and I was just thinking, and oh, it's really interesting. Let's go into. As I said, I need to be more formal and formalize it, but I have an idea, so I will do it probably during the time. Yes, yeah. The second part was about physics, classical and quantum, and the homotopy classes, and how the Cauchy theorem about the these homotopy trajectories and the homotopy and the integral over this homotopy homotopical equivalent trajectories are equal. It gives us, it rises the approach to physics, that it opens the door for the quantivity or quantizable processes. Yes. Yes, that was it. Yes, I just want to share this the endpoints that S has a minimum not in one trajectory but in the class homotopy trajectories, and it arises the how can I say, the questions and the further developments in that direction, that our particular point might move at the same time on the different trajectory, because they don't um, they are the same for this particle, and but different textures might have its own probability. Yes, that's it. And also, of course, we can put here, assign here the probability function. It takes one of the homotopy. For example, this. Let's say this is this homotopy map, and for each, for example, because the S here, oh yeah, here, S was the index, so it is index, and between points, so let's say between 0 and 1, to some 0 and 1 to the value of probability. So we can assign this probability function, and it gives us this quantum interpretation. Yeah. Yeah, but in that video, I really look like look like 1 minute. I will close this translation. Oh, no, no. Just my screen. Yeah, yeah. In this video, I don't want to seem really. Well, I'm seeming like someone who's just playing with words and some mathematical how can I say, some symbols and so on. So, but I'm just curious and wanted to share with you. Okay, thank you. That's it.